Hello everyone, here's our data from the mass versus volume lab. If you want to look right away on the y-axis, the first thing we'll graph is solid A. When we graph all of our values from solid A, we see they make a line. And that means as the volume gets bigger, the mass in each piece of solid A gets bigger. That's pretty fancy, but then let's think about solid B. Solid B we saw was heavier for the size. Each piece was like 10 or 11 times heavier than its volume. So let's see what those lines look like. So I'm going to graph solid B. And when we see that, oh my Lanta, look at that green line. It is much steeper than the red line. And if we look at like a piece, like these two pieces, they have almost the same volume. They're almost the same size, but solid B is way more massive than solid A. Each piece, if they're the same size of solid B, is more massive than each piece of solid A. One way we can talk about this is how heavy it is for its size is to look at the relationship between mass and volume. And a good way to do that is to see the slope. So let's find the slope of these lines. And you see mass, or solid B has a slope and solid A has a slope. They're clearly different. The slope of solid B is 12 grams for each and every milliliter. That means every milliliter of solid B is worth 12 grams. For solid A, it's not as much. Every milliliter is only worth 2.8 grams. And these numbers, how heavy they are for their size, how many grams are in every milliliter, we call that their density. So their density is how many grams are in each and every milliliter, or how much mass is in every single piece of volume. In this case, solid B is much more dense than solid A. Solid B has a density of about 12 grams in every single milliliter, and solid A has a density of about 2.8 grams in every milliliter. That means solid B is very different than solid A. Solid B has a lot of pieces stacked into every milliliter, almost 4 times as many pieces stacked in every milliliter than solid A. If we wanted to quickly look at water, water doesn't seem very dense. It doesn't seem like it has many pieces in every milliliter. If you look at this yellow line right here, or this, blue line right here, you can notice that. It's not very dense at all. It's not very steep at all. Its volume is about the same as its mass, and if we're going to find its slope, I wonder what it means. Since its volume is almost the same as its mass, we're going to see that its slope is equal to 0.99. It has a slope of almost 1 because its volume and its mass are almost the exact same. Great, this is density. We'll talk more about it soon. Appreciate it.